Hey there, welcome back. My name is Chris, and today on C# and Sensors, we're going to look at measuring distance using an ultrasonic distance sensor. Let's go wire this up. Today, as usual, we're going to use this YoshiPi. The reality is, this sensor uses a serial port, so any device that has serial with TTL level, so Raspberry Pi would work just fine, Meadow F7 would work fine, but I'm just going to show you here on the YoshiPi because it's got a display and it makes life easy. Again, this is serial, so really what we need to do is we need to connect up the serial, transmit, receive, power, and ground. And now we've got it fully wired. Let's go take a look at writing some code for this. So we'll create an IoT application. We'll name it, let's go with ultrasonic sample, just in case we do a different type of distance sensor in the future. The part number on this is an A02YYUW, which is not something that rolls off the tongue, but it's easy enough to find. We can go over here and do a search for that part number. And the Meadow Foundation driver is the only thing that even comes up. So we're going to install that. Now let's come over to our application. First thing I'm going to do is define the sensor. And then I'll create a sensor. Now remember, this is a serial sensor, so we need to give it a serial port. And the easiest way to get this is, again, since we're using the YoshiPi, we can just go to the hardware. And if we look at the bench, you can see it's on the microbus connector, so we're just going to use the microbus connector, and then we're going to say create serial port. Now this is a 9600 baud device, so we're going to provide that, and we've now created the sensor. Next, we're going to hook up an event handler for the data coming in, and we're going to tell the sensor to begin updating, and we're going to have it update say twice a second. Now down here in our event handler, we're just going to grab a reference to the display from the DI resolver, and then we are going to send our data out to the display. We get the distance in as the second parameter. It's a length unit, so we could output it in, meters, miles, inches, whatever, centimeters. I think just for this, we will go, let's go centimeters. The accuracy on this, I don't know, but it's probably not much less than a centimeter, but let's go 1 decimal point just because we can. And that's all there is to it. Let's build this application, deploy it to the device, and test it out. And you can see it comes up and we're already getting distance. This is probably something like to the ceiling above me or something like that. But if I rotate it sideways and we can shoot across what we have, let's move this up a little. You can see 20 centimeters, and it'll actually be accurate down to somewhere around 2 to 3 centimeters. Anything closer and it just doesn't quite get it. And then if I kind of try to shoot it across the room, somewhere around 90, it looks like that's where it's topping out, somewhere in there. So it's good in the, say, 2 to 50 centimeter range pretty well. As you can see, it's really simple to use this sensor, easy to set up. The code is very simple. It's great for something like a robotics project. In fact, we're going to use this on the YoshiBot project that we're in the process of building right now. That's all I've got for you today. Thanks for watching.